Okay, let's start off by just remembering how to evaluate a function. Now, we've already got here f of x is equal to negative x cubed plus 6x minus 7, and they're asking us to evaluate it at x equals positive 2. So largely what I'm going to be doing is writing that function exactly as it was before. You're not going to notice many changes, although I am replacing the x. And I like to put it in parentheses. It's not always necessary, but there are a lot of situations where it is necessary. And if you just get into the habit of doing it always, it doesn't really make anything harder, but it will keep you from errors in certain types of problems. So all of the function, all of that in red is still exactly the same as it was. The only difference is those x's I changed into 2. All right, so now we've got that first part where we've got 2 to the power of 3, so that'll become an 8. Then we have the negative, plus 6 times 2 is 12, minus a 7, 8, plus 12, minus 7 equals negative 3. All right, so that's all there is to that. Replace your x's with the number given, evaluate it, do the math. All right, usually I like to do all my exponents and multiplication first, and then I'll do all my addition and subtraction in the next step. All right, so we've got our function. We've got what to evaluate it at. I just write my function as it was before, only changing those x's, but nothing else should change. Only your x's will change. And all of my x's in this case were changing to 2. So 2 to the power of 3 is 8. Plus 2 to the power of 2, 4. Negative 5 times 2 will be a negative 10. Then minus 6. So 8 plus 4 is 12. Minus 10 is 2. Minus 6 is negative 4. All right, so that's evaluation. It's a quick, easy process. Make sure you know how to work with your negatives, both adding and subtracting. But if you've got that down, you're probably going to be okay. Next thing we need to talk about is what is a factor. Now, a factor is some number that will divide evenly into the number. And so let's just start with this. I can do 9 divided by 1, and I'll get a 9. So 1 divides evenly. I can do 9 divided by 3, and that'll give me a 3. So 3 is a factor. And I can do 9 divided by 9, and that'll just give me a 1. So 1, 3, and 9 are my factors. So these are numbers that I can divide by 9, and they will divide evenly. You can also think of them as these are the numbers that when multiplied by something else will give us that top number. So I can say that for 1, it's a factor because 1 times 9 is a 9. I can say that 3 is a factor because 3 times 3 is a 9. This ability to multiply to get that other number is what makes it a factor. Okay, 9 is a factor because 9 times 1 will give me that 9. All right, so now factors of 12. 1, 2, 3, 4, 6, and 12. And once again, because I can have 1 times 12 will give me 12, so 1 is a factor. 2 times 6 will give me 12, so it's a factor. 3 times 4, 4 times 3, 6 times 2, 12 times 1. So that's what makes these factors, that ability to either say 12 divided by 1 is a whole number, 12 divided by 2 is going to give me a whole number, 12 divided by 3, or the other way of I can multiply this number to get 12. Now, we still care about factors even as we start working with polynomials. And we need to know what are the factors, the things that will multiply together to give us x squared plus 5x plus 6. But we want to do it without remainders. Now, last year in 10th grade, you should have already found out that if we were going to multiply two numbers to get the 6, and we're going to add two numbers to get the 5. So the numbers that would add together to 5 but multiply to get 6 would be a positive 2 and a positive 3. So those two are my factors. Okay, x plus 2 is a factor, x plus 3 is a factor. I can do my x squared plus 5x plus 6 and divide it by x plus 2, and it will divide evenly. And let me just go ahead and show that. So 5x plus 6, if we're dividing all of that by x plus 2, then that's going to equal x plus 3. It will divide evenly without any remainders. Okay, I also can just multiply x plus 2 times the quantity of x plus 3, and I will get x squared plus 5x plus 6 because they're factors. Now, one thing to note is that our polynomial function is going to have the exact same zeros as our factored form. So if x were a negative 2, then that would become negative 2 plus 2. That would be a 0. And then 0 times anything else, doesn't matter what's there, that's also going to be a 0. So if at negative 2, our factored statement is a 0, then up top it should be as well. So negative 2 squared plus 5 times negative 2 plus a 6 plus negative 10 plus 6, and sure enough it does equal 0. They're going to share that property of if one of the factors would equal 0, then the entire expression would equal 0 as well. Now that's an important thing for us to remember, because that's the essential foundation of the remainder theorem. All we're asking here is this a factor? Is it going to divide evenly? We're not even going to do the division right now. We're just going to try to say, is it divisible? Okay, well, so rather than going through the process of division, I'm just going to notice, when would this be a 0? All right, well, p minus 2, so if it was 2 minus 2, that would be a 0. So I want to figure out if the first statement is going to be 0 at p equals 2. If it does come out as 0, then we probably wouldn't have a remainder. They share that 0. They share that factor, p minus 2. All right, so I just start replacing p's, just as we did with evaluating, with 2. Two to the power of 4 is going to be 16. 2 to the power of 3 is 8, and then times by a negative 8, we get negative 64. And then plus 40, plus 4, plus 4. So I'm going to get 16 minus 64, negative 48, plus a 40. All right, and we now have negative 8 plus a 4. We now have negative 4 plus another 4, and we just have 0. So both of these statements have a 0 at p equals 2. Yes, it is a factor. Okay, now that doesn't tell me what I'm going to get if I divide it. I'm going to have to actually go through the process of either synthetic or long division to know that. But I do know that I'm going to be able to divide by p minus 2 and get an even number. I won't have a remainder if I try that. That's what that has just told me when I got a 0. Okay, next one. So once again, I got n plus 5. So what number would n be to make that a 0? Negative 5. So I start replacing everything here, all the n's, with a negative 5. All right, so negative 5 to the power of a 5 will give me negative 3,125. Negative 25 times by a negative 125 is going to give me positive 3,125. And then we're going to have minus 175 plus 185 minus 18. It's pretty easy to see. Those two will become 0. Those are going to combine to become 10. So then 10 minus 18, answer is negative 8. Now, I did not get a 0. So even though n plus 5, if I used a negative 5, that's going to give me a 0. The n to the power of 5 minus 25n cubed minus 7n squared minus 37n minus 18, because it does not have a 0 at negative 5, then we know that n plus 5 can't be a factor. If it was a factor, it would have a 0 at the same place. So if I try to divide this, if I try to actually do that division, I am not going to get it to divide evenly. I'm going to get a remainder. And that is what us not getting 0 means here. It means that no, it's not a factor. And since it's not a factor, it will not divide evenly. And that's what the remainder theorem is for.